Hello and welcome to ipace.online. In this video we'll be looking at the options available for charging your EV. So you've taken delivery or ordered a new EV, but you're perhaps confused by the options available to you for charging. Over the next couple of minutes, we'll go through the various options and words and phrases being used to describe charging of an electric vehicle. First off are the speeds. You'll hear charging described as slow, fast, rapid, and sometimes even ultra rapid. But essentially, slow, fast and rapid are the three categories under which speed can be described for charging. Those different charging types come in two basic different forms. Firstly, you have AC. AC chargers are those typically found at your home, workplace, hotels, car parks, and the like. They are typically slow to fast chargers. They could have an attached cable or require you to plug in a cable. But these are the ones that are designed to give you a top-up or a trickle charge overnight. The other category are DC chargers. These are the ones you'll find at motorway services, out and about around the trunk road network, at hotels, fast food restaurants, pubs and restaurants, etc. These are the ones designed to give you a quick, rapid charge while you're out and about on your journey. If we now look at the different connection types, at the slow end of the scale you have the very traditional 3-pin plug, the one that we're all used to, the 13 amp socket. Most EVs will come with a 3-pin connector type to allow you to connect to a standard 13 amp socket. A typical 13 amp connection will probably draw down at around 10 amps, which is equivalent to around 2.4 kilowatts. A 3-pin plug is really the slowest option available and shouldn't be used as a long-term solution for charging a full EV. Also in the slow category we'd have the standard Type 2 connection. All EVs will have a Type 2 socket and most will be provided with a Type 2 to Type 2 connector lead. These are the sorts of things that you'll find at car parks, offices, etc. The Type 2 connector is ubiquitous and will not just be available for slow connections but fast and even rapid. The slower connections will be down at the 5 to 7.4 kilowatt connection types. A reasonably fast home connection will use a Type 2 lead, probably tethered, which means that you don't have to provide your own lead, and it will be up to 7.4 kilowatts. Moving up into the fast category, these will predominantly be Type 2 connections, ranging from 7 to 22 kilowatts. This is still all AC charging, and these are the ones that you'll find out and about at destinations, hotels, and other places on the road network. Some of these may be tethered, but in most cases you'll have to provide your own cable if you're out and about. Moving into the rapid section, there are still some Type 2 connections at this phase, with the 24 kilowatt ones provided by Ecotricity, for example, at the motorway services, but also in this category we move into the DC connections. DC connections are mainly formed from two different types. The first one is CHAdeMO. CHAdeMO is made popular by the likes of the Nissan Leaf. It offers a DC connection, mainly at around the 50 kilowatt mark. You can recognise a CHAdeMO connection by its rather bulky connection type that requires some sort of locking mechanism to attach it to the car. It should be noted that all DC rapid chargers will be of the tethered cable kind. You don't need to provide a cable to connect to these. Alongside CHAdeMO, we have the now most popular connection type of CCS. CCS standing for Combined Charging System, as you can tell from the diagram, uses the Type 2 connection with an additional 2 pins underneath it for the DC connection. They will always be as one single plug, but you may have to remove 2 grommets from your vehicle in order to expose both connection types. CCS connections range from around 50 kilowatts up to ultra rapid connections which are now around the 350 kilowatt mark. It should be noted that charge rates are highly dependent on several key conditions. Firstly, the vehicle. What is the state of charge, i.e. how full is the battery? What is the temperature of the battery and the ambient temperatures around it? And what is the type of cooling and battery management that is available on the vehicle? All of these affect the speed that you can charge at, regardless of the type of connection or available rate of charge. In addition to that, when charging at higher rates using the DC chargers, only the very highest rate of charge is available at certain peak conditions, i.e. low states of charge with good temperature in the battery. When it comes to how long does it take to charge, using the ipace as an example, to fully charge on a 3-pin plug, that would take in excess of 40 hours. On a 7.4 kilowatt home charger, that time reduces down to 13 hours and becomes the overnight charge. Out and about on a rapid charger, that same ipace would take just 75 minutes to do a full charge on a 50 kilowatt connection, and on one of the faster 100 or 175 kilowatt connections, that time would reduce down to 44 minutes. It should be noted that any speed above 50 kilowatts will notice a significant drop off once the state of charge gets beyond 60 or even 80% full. It's therefore not recommended to use a rapid charger beyond 80% because you do notice a significant slowdown in the rate of charge that is being accepted. I hope this has helped with the explanation of the charging options available. And as always, any questions, post them in the comments below. Thank you for watching.